So I'm just going to do that real quick, and I'll see you at the next step. Okay guys, so we're on to the next page, checks and first moves. This is a pretty exciting step because, well, I mean, I think all of them are pretty exciting steps, but this is the step where we're actually going to be like running the machine, which is very fun. You get to see it move for the first time. So I know my space is a little crowded here, but what we're just going to be focusing on is we're going to be taking out the control box, running the power supply. We're going to be checking that all the wires look good, plugging everything in, and then trying to run it for the first time. So preemptively, I'll let you know that you do need a computer for this step, but that'll actually be covered in the manual, so we'll get to that step soon. And I'm just going to set some of the other stuff aside, like the wrenches and all the other spare parts that we don't need anymore. The only thing you need now that everything is together is just your wood screws, these two plastic covers, which I'll explain later what they do. And yeah, that's it. All the other hardware, you should be able to set it aside and not have to touch it anymore. Okay, so we're off onto the left side of the machine. I've just kind of shimmied everything over here. And we've got our computer here and our remaining components, and some of the other stuff is over here. So we're just going to be taking out the things we need for this step. We need the power supply, control box, and the e-stop. I'm just going to open these all up. If you have wire snips, I would probably recommend you use them on this zip tie rather than an X-Acto knife. Else you risk cutting the wire for the e-stop. So don't do what I do. Okay, I'm actually having a lot more trouble with this than I thought. Come on. There we go. So, in this box here is what we call the Longboard. It's the control box for the machine, and it contains all the electronics for allowing your computer to talk to your machine and move it around and have a bunch of other controls available to you, that some of which you might only ever use if you go to modify your machine more. So the interesting thing about the box is it's got 4 mounting holes on either side, so you can mount it to whatever surface you want. And this e-stop switch basically serves as a on-off switch for the box that plugs into the top side here. Meanwhile, the power supply plugs into the back side. So we're just going to go through, as the manual shows, the checks on all of the wires and whatnot. And just seeing that the polarity is correct, giving a tug test on the connectors to make sure that they're all attached firmly, checking the motor wires and doing a tug test on them to make sure they're all attached firmly. And after all that's done, we can go ahead and start plugging everything in. So I'm going to find the short wire first, and that's going to be my Z-axis. And make sure you really wiggle these firmly all the way in so that you have a very reliable connection. And I'm going to get my X next, because my X is the other one that comes out the drag chain here. And you can see the labels in the box, so you know which one you're going to be plugging in. really snugly seat these in, guys. And then for the two y-axis motors, the order of these doesn't matter. So you can put whichever one you want on Y1 and whichever other one you want on Y2. There we go. And we're going to plug in the power supply here. Plug it in from behind. Once again, pushing it all the way in. We're going to just leave all these things loose on the table right now, but at a later step, we'll cover the process of how to attach everything down so that nothing's moving around on you and the wiring of the motor is clean, and even this power supply can get a little warm over time, so keeping it out of the way so you're staying safe. So I'm just going to run an extension cable up to the router and also to the power supply so that I can show you how the e-stop works and where the power light for the longboard is. Okay, so once you got power to the machine, you should notice that the e-stop button, when you untwist it, you just follow the arrows. It'll turn on this red-orange light here. That's your power light for the longboard. And that shows that you've got power. And you notice when you push it back in, the power goes off. Another thing that you can check out is on the underside, there will be 4 more red-orange LEDs, and each of those is coming from the motor drivers. These will drive current and the voltage to each of the motors to make sure they're moving correctly. So now with all of that confirmed, we're going to bring our computer over here and our USB cable. And this is a very common USB cable, so it's very easy to find if you need a replacement. But we've got the ferrite on here as well in order to reduce static coming through the signal from your computer to your machine. And you should notice that you can plug this in on the USB type B side into the side of your longboard here. And then on the other side, plug it into your computer. There we go. So, as the instructions show, to move on to the next step, we're going to be downloading what's known as a G-code sender onto your computer. And this is just a program that allows you to tell the machine what you want it to do. It's basically your window into controlling it or interfacing with it. And so these go by many names. We actually have our own in-house software that can take care of this for you. And the reason why we spent the time to make it is actually because we used to use a lot of the third-party options, and occasionally our users would have issues here and there. And so we decided to work on our own that solved all those problems. And so I would highly recommend you use it, not just because I think it works really well, and also not just because I happen to be the lead developer or the lead on developing the program. But in any case, you can follow this link, and that'll take you to a page where you can download the version that you need for your computer. So whichever version your computer is, most computers are Windows 64 machines. And I already have it downloaded, but I'm just going to show you what the download looks like. I think, oh, here we go. You can see the download started up here. Now this takes you to the page to learn more about installing the machine or installing the software and using it. But I'm going to give you those details myself so you don't have to worry about it. So this is going to download, and then you would have to run the installation steps for it, which would be on that previous page. Once you're done installing it, it's just a matter of clicking this to run it and clicking more info so you can run the setup of the software. And then this will take you through the process of installing it onto your computer. There will be kind of an installer here, and you just hit agree to a couple things and you'll be finished. Now I've already got it installed, so we're just going to open it up here. And you can see what it looks like. And just like what's shown on the instructions, you can see we're going to basically ensure we've got the machine plugged in, i.e. the USB cable running from the computer to the control box. And then we're going to hover over the top corner here, and you should see an option pop up that you can connect to. So in this case, it's called COM20, but for you it might be something different. And we're just going to click on that. And I'm sure you guys heard that. There's this little hum thump that you can hear come from the machine, and that's a really good sign. That tells you that the connection has been made successfully, as well as you can see here that it now says connected at the top, which is another indicator that you've connected correctly. And basically, you don't need to learn much about how this software works right now. But the reason why it's needed for the machine assembly is because, well, A, we want you to start to become familiar with the interface you're going to use to run your machine. But B, we also, when we're mounting the machine to the tabletop, we're actually going to want to move it around so that we can mount it correctly. And that's using this area here called jog control. When you're moving the machine around, it's usually referred to as jogging. It's just a CNC term. And so in the context of, you're not running a program or anything like that, you're just kind of manually controlling it. That's when you're going to use this jog control area to the right side here. And if you don't like it on the right side and you want it on the left side, you can go into the settings. Where was it? And toggle this guy here, and you can put it on the left side if you want. But I like it on the right. And all you really need to know about this is that you've got the movement in the X, Y, and Z directions, and these movements will correspond to the directions for your machine. You've also got the amount of movement you're going to get when you click one of these buttons, and also how fast it's going to move. And we actually have these 3 different presets for moving either larger distances at a faster speed, a normal distance at a normal speed, or a smaller distance at a slower speed. So this is very handy for adjusting your speeds and distances on the fly. And basically all you really want to check for right now, because we're on this page called Checks and First Moves, is just to make sure that the machine is moving. So if I click the X minus, I should see the machine move in the X minus direction, or the left, moving it to the left. The X plus should move it to the right, or in the X plus direction. I've got the Y plus, the Y minus, the Z minus, and the Z plus. You've also got diagonal movements you can make if you want. And the other cool thing about these is that if you click and hold them, it'll also continuously move in that direction as well. And here's an instance of me choosing a faster speed or a slower speed. And it's pretty fun, huh? The noises that the machine makes, it's almost like it's singing a robot tune to you. The only other things that are really worth covering here is if you have your motor on the other side, you'll want to go into this firmware section here and invert the direction of the x-axis so that you get the right movements in the right direction. As well as if you prefer movements in inches, you can go into the settings and change it to inches, and that'll show you all your inch movements instead. So now we're going to take a step away from the computer for a moment and focus on the mechanics of the machine, basically to finish tightening down or preparing the machine so that it can make accurate movements while also moving rigidly. I've introduced this concept to you guys earlier in this assembly video, but basically what this tuning movement section is going to include is adjusting the offset or eccentric nuts on the wheels to make sure that they are getting the correct spacing between the top and bottom wheels, as well as we're going to be adjusting the bolts to the anti-backlash nuts so that those are set to the right setting so that you're not getting any slop in the movement along that direction. And once you're finished checking those two things, those will basically decide the accuracy as well as the rigidity of the machine. So I'm going to demonstrate it to you more closely with this y-axis gantry here. And then after I talk you through it, you can feel more confident in doing it yourself on the other axes, while I also do it on the other axes. If you still are a bit unclear based on the explanations I give, you can also scroll down on the page and you'll find a link to a video where you see me explaining it, and that has graphics that go along with it, so that might clear things up for you. But fundamentally, all we were trying to keep in mind here is that these wheels have adjustable spacing on them. And if they have adjustable spacing, there's going to be a spacing that puts them at the right spot, that they are holding on to the top and bottom of each of these rails the correct amount. You don't want to clamp them too hard down because that would put extra stress on the wheels and on the fasteners, and it would even make it harder for the motors to rotate and move that axis. But you also don't want them to be too sloppy, because right now they're very sloppy, right? And you can see how much I can wiggle the machine around by, and that would have bad consequences for cutting something out accurately. So looking at the y-axis, you can see a close-up of when the nut is the most open and when it's the most closed. And you might also remember that we never fully tightened these down in the first place. And so basically where you're just going to start at is you're just going to start by tightening the two wheels down on the gantry you're working on. So in my case, it's the left y-axis gantry. And with these tightened down, I'm now going to check. And what I'm checking is the rotation on the wheels. What you should notice is the rotation on the wheels, and you're going to check these in pairs, top and bottom pairs. They should be between the two of them so that you can turn them, but only that you can barely turn them. Right now they turn very, very loosely, both the top and bottom pairs. On both the front and the back. The top wheel, I can turn barely, but the bottom is very loose. And so what we're going to do is we're going to focus on one pair at a time. So I'm going to do the front wheel first. And basically all you're doing is you're going to use the Allen key to open up to loosen the bolt going towards the or the bolt that holds the wheel in place. Then you're going to take your wrench and you're going to rotate the nut in a way that reduces the distance between the two wheels, because that rotation is going to move the wheel closer to the other wheel. And once you make that rotation, you're going to then tighten the wheel back up, or the bolt that holds the wheel on. And then once you tighten that down, you're going to check again. How are these wheels feeling? Are they too loose? Mine are too loose still. So I'm going to loosen the bolt again, turn the nut, and then tighten the bolt again. How are they feeling now? They're much better, but I can still turn them much too easily. I should be struggling a little bit to turn it. So I'm going to loosen it again, turn the wrench, and tighten it again. Okay. This is actually, I've hit the right sweet spot here. Usually you can accidentally tighten it too much, and then you'll go and check the wheels and you'll find it's impossible to turn one or both of them. But I've hit the right spot. Both the top and the bottom wheels I can turn. It's a little hard to turn them, but I can turn them. So I've hit the nail on the head with adjusting these. And with that success, I can move on to the back set of wheels. Oh, I should mention, while you're working on your machine, I would encourage you to power it off, because then that way you're just being extra safe. So the steps that I followed on the front set of wheels, I'm also going to follow on the back set of wheels. And you can see these annotated in the assembly instructions as well. You're just loosening the bolt, twisting the nut, tightening the bolt, checking the wheels. Now, I just have reached a point for this back set where the top is actually really, really hard to turn, but the bottom is less hard to turn, but much easier to turn. Like I can turn it, it's not loose, but it's not tight either. But because these kind of come in pairs, the wheel pairs exist, if this one is quite hard to turn, but the bottom is a little more on the loose side, I can kind of average the two out and say, well, if this one's really tight and this one's or if this one's a little bit more on the tight side and this one's a little more on the loose side, then as a pair, they're actually in the right spot. And so these are now actually good. They're at the correct point for tightening for setting the location of the eccentric nut. So I'll just make sure that they're both snugged up. And I've now done that one y-axis gantry. So I'm just going to move on, and you only need to do this on the two y-axis gantries and the x-axis. And the pictures show both where the nut should be initially, which is open, and then where you need it to be, which is closed. And they also show, as I said, the process of opening and closing them. Now, while I'm doing this, I'll give you guys a little bit of a background on why these eccentric nuts are located on the top versus the bottom, because for the X gantry, they are on the bottom, but for the Y, they're on the top. And basically what the reasoning for that is mostly for your own benefit, because once you have the eccentric nuts too far out of the way, it can make adjusting them much more difficult. And you don't, adjust the eccentric nuts very often, but when you do, having them in a location that's more easy to adjust is better in the long run. And that's one of the main reasons why they're on the top for the y-axis and on the bottom for the x-axis, because you can see if it was on the top for the x-axis, the drag chain's in the way, and if it was on the bottom for the y-axis, you'd have to be reaching under the rail quite a distance. Now, depending on your background, if you are a bit more technically inclined, it might seem like a bad choice putting eccentric nuts on the top, because you'd think that the fixed nuts should be on the top. But in actuality, it doesn't matter which side they're put on. Because one set of wheels is always going to be snugged up to the other set of wheels, the fixed wheels will always be the basis for aligning the plates, whether they're put on the top or on the bottom. And so as long as you keep that in mind, you'll see that the design doesn't really care which side you put the eccentric nuts on. So yeah, there's some of our thought process on doing that. Another perk to having them located where they are, which wasn't really factored in for the design, it's just something that I noticed after the fact, is that by having them on the bottom for the X and on the top for the Y, it kind of gives you a single plane to check when you're doing maintenance. You're not having to kind of look around the machine and see, okay, what am I going to be adjusting next? It's pretty easy to see that you just gotta work on the top nuts here and the bottom nuts here. They're all right next to each other, so it makes it easy on you. Okay, so I've definitely just slightly over-tightened these wheels just by a smidge, because the top one is kind of hard to turn and the bottom one is kind of hard to turn. So, just gonna open it up a bit, twist it back just ever so slightly, close it again. Yeah, now that feels good. This process takes the longest initially, and that's because depending on the rail and the wheel and a lot of these other variables, it's hard to know where the nut is going to turn out right off the bat. But once you do have the nut positioned after the first time, then you don't have to worry about finding that position again later on, because it's always going to be in the same place. And then every time you do maintenance on the machine, if you have to tighten the wheels, you're just going to be turning the nut ever so slightly and then tightening the bolt back down, and that's it. So the process becomes quite easy. All right, so all of the V wheels are tightened down using those eccentric nuts. And what that should mean is that if you go to twist the plate in this plane, that it feels nice and solid. There's no up and down like wiggling or anything like that. Now you will notice some side-to-side wiggling, and that's fine, because the next step is that we're going to be checking the anti-backlash nuts, the robot heads, making sure they're all good. So the first step to that is tightening the bolts for all of them. And just like we've done many times before, we're just going to alternate between the two bolt heads to make sure that nothing gets twisted. So there's the one on the Y. And we're just going to do the 2Y and 1X because we already did the Z much earlier on in the assembly. And the X one is a bit harder to find, but you basically just want to move the Z all the way down. And this is the easiest way to access it. Here are the 2 bolts here. It also is, I think, possible to access it with the Z all the way up. So do it whichever way you wish. If any of you are sleeping right now, please wake up. I know this part of the assembly is, in my opinion, is the most boring part because you're doing very little. Visually, it seems like you're doing very little with the machine, but really this is where you make or break the accuracy of the machine, is the time that you spend on setting this up. Now, mind you, I wouldn't necessarily encourage you guys to spend all this time up front to get it perfect. I would say just get it close, and then we can move on to doing the other stuff, and you can always come back to this, but that's up to you. So once all of these are fastened down, basically you're now just going to be checking for back and forth looseness. And what you should notice, at least for now, is, and you're checking for back and forth looseness in all directions, even on the Z. What you should notice right now is that there's no looseness on any of them, which is good. Basically what will happen over time is, you remember how when we assembled the anti-backlash nuts, let me just grab one here. We threaded that bolt in, and this isn't the right size bolt, this is just a demonstration. We threaded that bolt in, but we stopped about halfway, right? So basically what we're going to just do now is we're going to keep threading it until it just barely touches, it just barely grazes the other side, but no more than that. And the reason why is because these are all tightened up, so you don't need to do anything else. But when you do come back to this, if you check your machine and it feels a little loose, like it's wobbling ever so slightly, then that's when you're going to go and tighten this bolt with your Allen key. And it's kind of hard to see, but by tightening this bolt, it's kind of spread these 2 sides apart. And because there's a threading for the nut, for the lead screw here and for the screw here, by separating these parts, that's going to take up the slack, the wiggle that you see in your machine. And so you can go back to whichever axis you need to and tighten that up. For the time being, we're just going to finger tighten the ones we can reach and just get these to a spot that is just very lightly touching the other side, as I mentioned. I would say out of all of the screws, the X-axis backlash screw is the hardest one to reach. But once again, just like for the eccentric nuts, once you have it roughly positioned, you don't really need to access it a whole lot. The one thing I am going to do here is I'm just going to jog the machine backwards for a moment so that I can access the Y backlash nuts a bit easier. Put it on rapid. There we go. And for the X and for the Y, you'll notice these little notches, and those are going to show you where roughly the location of your screw is. I'm just twisting the bolt until I feel even the smallest amount of resistance and I'm stopping. Because if you go any further, then that's going to start to spread those two parts of the backlash nut apart. It's going to open up the robot's mouth. And right now everything is very snug. So if I open the mouth in its current state, then it's basically going to be putting more tension on the lead screw than is needed because, I don't need the machine to be any more accurate right now. So if I over tighten it, I'm just going to wear those components out prematurely, essentially. And to finish off this page, we're just going to put these covers on. These were just we actually spent a long time designing them, but we designed them in a way that they are going to fit over your locking Acme nut covers, or your locking Acme nuts. These are the covers for them, and they just pop over top. And the reason why we felt we needed to make these was because we wanted to avoid, if you were leaning over your machine while you were using it or what have you, the possibility of your shirt snagging on the bolt that sticks out on these. And so these kind of make more of a cam shape that will keep you a bit safer when you're near your machine while it operates.